Right, this is our lesson on the chain rule. So this is going to allow us to be able to basically get the derivative of virtually everything that we're going to deal with. So the problem we've had now is we can only just do basic powers and trig functions and things, and we couldn't do anything that was a combination of those. We could do products and quotients, but now we need to do if there was a composition of functions. So now we have a function inside another function, and we need to be able to figure out how to do the derivative. So we have something called the chain rule. It's really important that you get this correct, that you work really hard to learn how to do this rule and you learn it correctly. So you're going to want to be checking answers and verifying that you're doing things right. So if we have a function y equals f of u, where u is some function inside. So we will typically use u and v to mean that there's some function of x, like sine x or x squared plus 3x plus 4, or some other function of the same variable we're using, so of x in this case. And so we'll have a function, so it would be y equals f of g of x. So again, there's an inside function, and sometimes there might be inside, okay? And so in Leibniz notation, it looks like this. We'll use that sum, but this one is primarily the way that we will think about it. So what it says to do is do the derivative of the outside function, leaving the inside alone, times the derivative of the inside. Okay, so that's how we'll do it. So examples will help make a lot more sense. So again, we'll use different notations and then you'll kind of see as we do it. All right, so we're gonna actually skip doing this with and without the chain rule thing, and we'll come back to it possibly. So you can kind of skip that for the moment and go to example 2. Sorry, everything's going slow. Oh, I guess example 2 isn't on here. Okay, so I'll write example 2 down. So example 2 says to find f prime given that we have f of x equal 4 minus x squared cubed. So prior to the chain rule, the only way you would have been able to do this is you would have had to multiply 4 minus x squared times 4 minus x squared times 4 minus x squared and get a binomial, which we don't want to do. So luckily now we have the chain rule. So remember your notation. Always write that I'm doing f prime of x. And so what we do is we just recognize that the outside function here is cubing. So inside is clearly 4 minus x squared. So we ignore that for the moment and we just do, what do we do when we're cubing something and we want to do the derivative? Well, we put the power in front, we leave the inside alone, we lower the power by 1. Now, because it's the chain rule, I take it times the derivative of the inside, because the inside is now not just plain x. It's not just this variable. So anytime the inside part of the function is not exactly what's in the parentheses, then we have to multiply times its derivative. So the derivative of 4 minus x squared would be negative 2x. And then all I want to do is a tiny little bit of cleanup, and then that's all you should ever do on these problems, because remember, we don't know what we're using them for later, so don't do a lot of simplifying. So I'm going to take the 3 times the negative 2x and just put it in front. Okay, so just multiply that out, and then that's it. So, and that's about, like I said, about all we're going to do for cleanup. Okay, so there's this, oh, there was the thing there, I didn't even see it. All right, so general power rule, we're actually not going to actually do this because it just makes it like something else to memorize, and it doesn't matter. You're just always doing the chain rule anytime there's an inside and an outside function. All right, so let's go to example 3 here. So we're gonna do almost all of these, but we'll do some of them in class as a review. So when we do this first question, so this is similar to the issues that we would have in doing this if it just was a power of x. I have a square root. I have no rule for square roots. I have rules for powers. So we're going to rewrite this as x squared minus 1, and then the inside is cubed, and this is square root. That's a 2 for the root. So remember, it's power over root. So there would be your new power. So now to do the derivative, I again recognize that the outside is the power and the inside is the x squared minus 1. So I just follow the power rule. So I do power in front, leave this alone, lower the power by 1, times the derivative of the inside, which is 2x. And that's it. That's the chain rule. Okay, and then again, last thing, only thing I'm going to do to simplify it a bit is do 3/2 times 2x, which would be 3x, and then x squared minus 1 to the 1/2, or you could write square root of x squared minus 1 if you want. I like to just leave the exponents because they're usually what we would do more of later. Okay, when we look at B, so when we did the quotient rule, I've made the comment a couple times that as soon as we learn something else, we'll never use the quotient rule if the top is a constant, which is what we have. So you could use the quotient rule here, but you really, really need to focus on saving yourself a lot of work. And when the top is a constant, do not use the quotient rule. So I'm going to now rewrite this, leave the -7 is in the top, but I'm going to move the bottom term and make it a -2 at the top. Remember that negative numbers have nothing to do with moving things up and down, but negative exponents work different. So exponents do change things and become negative when they go the other direction, not numbers. Numbers have never changed what they've meant ever since you learned what a negative was. So now it's really easy to do this derivative. So remember, when you have a constant, you just kind of leave it. So in this case, I'm going to do, again, the power rule. So I have -2 times the -7, so that's 14. Leave this inside alone. Lower the power by 1. So be careful there. It's a negative exponent. So you subtract 1, you'll get -3. And then times the derivative of the inside, because the inside is not x. So when it's not x, you have to multiply times its derivative. Then again, the only thing I would do is I would clean this up, and I would leave it, because now I certainly could match. If I was on multiple choice, I certainly could look and see that this answer was the same as my answer, right? So I tend to want you just to stop when you get to the point where it would be easy to match, okay? All right, so let's do C. So here, let's remember that we have a y, so we're not going to write y prime. We're going to say dy dx. I'm doing the derivative of y with respect to x. I again have a power. So I'm going to put the power in front, leave the inside function alone, lower the power by 1, so 2/3 minus 3/3, times the derivative of the inside, which is -8x. I would say all of those words to help yourself. So power in front, leave everything alone, lower the power by 1, times the derivative of the inside. And then again, just clean things up a bit. So I'm just going to have -16x over 3 times 5 minus 4x squared to the -1/3. And again, if you want to put that in the bottom, you can, but I'm close enough to match something, leave it alone. Okay, so let's look at D. So now we have something other than a power here. and I have e. So I'm going to do the derivative. So again, I write dy dx. That's absolutely necessary. And I look at this function, e to the 3x squared, and I have to decide what's outside and what's inside. Well, clearly 3x squared is inside e to the x because it's the exponent. Another way you can tell what the inside function is if I said, I want you to plug in x equals 1. Well, what would you do first? Well, you would take 1 and square it, multiply it by 3, and then you would do e to that power. So that means that the 3x squared is inside. So this is the inside function. So what I do is I think, okay, outside function, how do I take the derivative of e to the something? Well, it's the easiest one there is. It's e to the something. Now the difference is my something, my exponent, is not plain x, which is what I'm doing it with respect to. So I have to multiply times the derivative of the inside, which this was the inside function. Now, like with trig functions, often what I would have done from the first step is I would have said, okay, it's e to the 3x squared, and I would have left a space times the derivative of the inside. So I would have just gone in that direction from the beginning because I knew I was going to have to multiply by something, and we prefer those things in front of e. Okay, so just get in the habit of, do leave your answers like this. That is because it does cause confusion if they're written the other way. And like I said, just like with trig functions, I kind of just write the e function out there and leave a space in the front to do the derivative. Okay, so here we have another one that looks like you could use the quotient rule, but I'm not going to use the quotient rule because the top is a constant. So write that down, say that to yourself 100 times, but no quotient rule if the top is a constant in most cases. Sometimes with some trig stuff might be easier, but with regular type functions like polynomials type things in the bottom or these type things, I'm going to just change it to a power and make it a product. So I have -2, and then this is 6x plus 3 to the -1/3, because of course it's to the 1/3 in the bottom. And I know I want a power, because again, there's no rule for square roots or radicals of any kind. So I need to change it to a power, and then I have a rule for that. So now I'm going to do the derivative. So again, I write dy dx. So I have a power with an inside, so again, same thing. I'm going to multiply, so I get 2/3, leave the inside alone, and then lower the power by 1/3 minus, or -1/3 minus 3/3 would be -4/3, times the derivative of the inside. So anytime this inside is not exactly that, okay, I have to do the chain rule. So the inside was 6x plus 3. That's not just a plain x, so I do times its derivative. Now I just clean it up a bit. 2/3 times 6 would be 4. And then again, just leave this 6x plus 3 to the -4/3. Okay, and leave that alone. All right, so now let's do one that's a little bit different. So this one actually has kind of an inside and an inside and an inside. So we're going to see where the chain rule has to happen sometimes more than once. So hence why it's called the chain rule, you'll see when we do this problem. So remember, this is a video, so you can also pause, rewind, rewatch things. That's the advantage to it. So first thing I'm going to do, so anytime you have a trig function and you're going to do the derivative of it and it's raised to a power. So this means cosine e to the 5 theta cubed. I'm always going to rewrite that. So this is cosine e to the 5 theta whole thing cubed. So that's one of those things, write that down in your notes. Pause it, write it right here, write it on the front, write it in your notebook. But somewhere, write down for yourself, anytime you have a trig function that is raised to a power, so we have that notation where we put it in the middle there, rewrite it so that you see the power better, okay? because now it's much easier for me to see the outside and the inside functions. So I clearly see that this whole thing is inside and my power is my outside function. So I do 3, put the power in front, so 3 times, leave the inside alone, lower the power by 1. Now I have to do times the derivative of the inside. So on the inside, I actually have a function inside a function inside another function. So I have to decide what the outside function is here. So in here, the outside function would be cosine. Again, if I gave you a number and said plug it in, think about all the stuff you would do first, and whatever you would do last is the outside function. So ignore the e to the 5 theta for the moment and just think, what is the derivative of cosine? So that's going to be minus sine, leave this inside alone. Now, this inside, oh, and I wrote dy dx over here, sorry, let me write that d theta. That's important because that's the variable we're doing now, so d theta. So the inside, again, is not plane theta, so I have to do the derivative of this inside. So I've done, again, let's go back to the beginning. I did power in front, leave everything alone, lower the power by 1, times the derivative of the inside. On the inside, I have more than one function, but my main function is cosine. So I did minus sine, leave that all alone. Now that inside wasn't plane theta, so I have to do times its derivative. So times the derivative of just this e to the 5 theta. Well, we just did an e, so we know that that's going to be rewrite e to the 5 theta, because that's the derivative of e to the something. But then its inside, also not plane theta yet, so times 5. So this should be a perfect example for you to see why it's called the chain rule. Okay, so we're just chaining together all those derivatives. Now I'm going to clean it up. So I'm going to put all the like single type things out in front and leave the other stuff at the end. So I'm going to do my 3 and my negative and my e to the 5 theta and 5. I'm going to put all those in front. So that'll be negative 15 e to the 5 theta times, and it doesn't really matter, I'll write sine e to the 5 theta first and the power 1 second. It doesn't make any difference which order those are in. Okay, and then there you go, that's the answer. Now be careful that you don't get lost in doing the chain rule, or that you don't accidentally think that every single time anything, when you get this next derivative, that you just keep going until you get down to 0 or something. That's not the case. So you have to kind of say the words to make sure you're following. Now, this example, I could do the rule right where it is on G, but remember that with LNs, we want to use the power or the properties of LNs first. So this is another one of those things to write down. So you want to use the properties of LNs to simplify things as much as you can before you start doing the derivative. So here, the ln of something to a power, the power can go in front. So this is not the derivative at all. This is log properties. Okay, so I would again make a note to myself, because again, these are your notes. So pause and write down, hey, remember when you have logs, to use the properties of logs to simplify as much as you can. I cannot simplify ln of x squared plus x plus 1 because there's no rule for ln of a sum. There's rule for ln of a product, but not ln of a sum. So now I'm going to do f prime of x, and now I'm going to do this derivative. So 2 can just hang out there. Now, the way I want you to now learn the derivative for ln, okay, so this is even one of those things you can write down also. So the derivative of ln of u. So now this is, I've got something inside that is not just plain x. You're going to learn that as du over u, meaning the derivative of the inside over the inside. That's the way I would say it. It will make life so much easier. So if I'm going to do this derivative, I do the 2 is kind of just hanging out. Then it's times the derivative of the inside, 2x plus 1 over the inside. That will help you tremendously later when we do integration. So just trust me that this is the way I would now want to memorize the derivative of ln. So instead of derivative of ln of x is 1 over x, I want you just to always think the derivative of ln of u is the derivative of the inside over the inside, du over u. Okay, that will make a huge difference to you, and you can just leave this answer exactly like that. Okay, we're going to do h, and then we're going to do the rest of these we will do in class as kind of a review of everything. So for this one, I need to recognize first thing that there is a product here. So I have to use the product rule. As I say the product rule, I just have to handle derivatives as they come. So I'm going to say first times the derivative of the second. So now forget everything for a moment and just look at your second term and focus on how I would do the derivative. So the derivative of e to the something is e to the something. Here's that me leaving a space, okay, because I know I'm going to take times the derivative of the inside. So again, my process is first times derivative of the second. So that's what I'm in the middle of. So derivative of e to the something is e to the something times the derivative of the inside. Well, this is going to be negative 4 over x for the derivative of negative 4 ln of x, because you'll have the negative 4 times whatever answer I get, and you'll have derivative of the inside, which is 1 over x. So now I've just done first times derivative of the second. So now I have to do plus the second. Now again, I'm going to leave a space here, just like we did with trig functions, because I know I'm getting ready to multiply. So that's the second times the derivative of the first, which is 2x. Now I do still have a little bit of cleaning up to do, so it wouldn't have really mattered on that second term, but I want to distribute this x squared times that. So that's going to give me negative 4x, because I have x squared on top, x on bottom, e to the negative 4 ln of x plus 2e to the negative 4 ln of x. And I would just leave my answer exactly like that. If something factored something out, or actually I guess I could add those together now, though those are actually like terms. So I can go one more step in this problem by recognizing that that does add together. So that's going to be negative 2x e to the negative 4 ln of x. Now, I do want to say one more thing about this one. You're going to be on a test and you're going to look at it and it's not going to match anything. Okay, because we just went through this whole process, which we could have done the problem different, and we'll start class with that next time. I want you to think about it. But you're going to look on multiple choice and this isn't going to be there. And you're going to think, oh my gosh, what did I do wrong? Here's what we need to remember. E to the negative 4 ln of x can be simplified a bit. You can rewrite this as e ln of x to the negative 4, because remember, powers can go back up to the making a power, and it's not x to the negative 4, it's x to the negative 4 is the part of it, not the whole thing to the negative 4. So when you have e to the ln of x to the something, you just end up with the something. So that actually ends up being, e to the ln of something is just the inside. So I end up with just x to the negative 4, because e and ln are inverses of each other. Okay, so that means that this is really negative 2x times x to the negative 4, which is negative 2 over x cubed. You'll move x fourths to the bottom and you have 1 on the top. So you can see here where this and this would be a little bit hard to match. Now in class next time, so I want you to think about, what if I had done this first? I want you to think about what would happen to the derivative, because that's another way to do it. Okay, so there's not just one way to do a problem, so we do have to be good at sort of matching things. Okay, that is important. So that's it for this video, and then we'll do the rest of the examples in class as a way to review.